Hi friends, welcome to our channel Jayadithya Math Tutorial. We are doing a series of 10th class mathematics. As a part of this, we are now in the chapter tangents and secants. Already we have done 3 important classes on tangents and secants. If you don't watch them, please do watch them. And the one thing is, if you are new to my channel, please do subscribe, and if you like my classes, please do like and share with your friends. In this class, we are going to discuss about some important problems of exercise 2. So without wasting any time, let us enter into the class. Okay. Right, the first question is two concentric circles of radii 5 centimeters and 3 centimeters. So there are two concentric circles, it seems. What do you mean by concentric circles? The circles which are having same center but different radii. The circles which are having same center but different radii are known as concentric circles. So these are the concentric circles with center O, let us think, and he has given the radius of one circle is 3 centimeters. So let us take radius of one circle as 3 centimeters and radius of the other circle as 5 centimeters. He has given the radius of other circle as 5 centimeters. So let us draw like this. So this is 5 centimeters. Okay, if you want, you can take these as small r and capital R also. Okay, small r is equals to 3 centimeters and capital R is equals to 5 centimeters. So what is our question is, find the length of the chord of the larger circle which touches the smaller circle. So there is a chord, it seems, there is a chord for the bigger circle which touches the smaller circle here. There is a chord for the bigger circle which touches the smaller circles, and we need to find length of that chord here. So let us take the chord as AB here. Let us take the chord as AB. You need to find the length of AB. Okay, and if you observe how to find the length means, here you will be using Pythagoras Theorem. How means, if you draw a perpendicular from the center to the chord, or it will be the tangent to the smaller circle, right? AB will be the tangent to the smaller circle. You know that radius is perpendicular to the tangent. So here the radius is perpendicular to the tangent. So I can take here angle as 90 degrees now. Let us take this point as some D. Let us take the point as D now. Okay. So now we need to find the length of the chord. You know that perpendicular drawn to a chord will bisect it, right now. So from that, what you can write here, so this will be AD will be equals to DB, which is equals to how much, Nana? AB by 2. Perpendicular drawn to a chord from the center will bisect it. This is the statement we have discussed in our previous classes. We have discussed many important statements in our previous classes, Nana. You must and should know them. So that's why I am asking you to watch the previous classes. Please do watch them. Okay, so see here how to find means, if you observe OD will be the radius of the smaller circle, right, Nana? OD will be the radius of smaller circle. So this also becomes 3 centimeters. Nana. That also will be 3 centimeters. OD is equals to how much here? OD will be 3 centimeters. And also, if you draw the radius for the bigger circle such that OB, Nana, if you draw OB, if you join O and B, that will be the radius of the bigger circle. So what is the radius of bigger circle here? That is 5 centimeters. Radius of bigger circle is 5 centimeters here. So you write that one. OB is equals to how much, Nana? That is 5 centimeters. OB is equals to 5 centimeters. So there you can observe a right angled triangle, Nana. So what you can observe there? Triangle ODB. Triangle ODB is right angled triangle. That is right angle triangle, and right angle like D, Nana. Angle D is equals to 90 degrees. Therefore, what is our hypotenuse here? Our hypotenuse will become OB. So you can write here by using Pythagoras Theorem, OB square will be equals to OD square plus DB square by which theorem? Pythagoras Theorem. Substitute all the values here. This is 5 square is equals to OD is nothing but 3 square, which plus DB square, now DB square here. So this is 25 and this is 3 square. If 3 square comes to left hand side, it will be minus 9, which is equals to DB square. So you can write DB square is equals to 16 and DB is equals to root over 16, which is equals to how much? 4. DB is equals to 4 now. So from equation 1, what you can see here, DB is equals to AB by 2. So which is equals to AB by 2, Nana. So AB by 2 value is 4. What happens to AB now? AB is equals to 4 to the 8 centimeters. The AB is the required chord length, Nana. Okay, so in this way you can solve this one. And in the previous class we have discussed construction of tangents. There we have missed one concept, that is how to draw a pair of tangents to the smaller circle from a point on the bigger circle for a concentric circle. For example, this is the same problem. Let us see here. For example, he is asking us to draw pair of tangents from a point on the bigger circle to the smaller circle, means how to draw it. So let us draw once again. Right now, if you observe here, take two concentric circles. So this is one circle, and let us take the other one as like this. Okay, there are two concentric circles. For this you need to draw pair of tangents. For the smaller circle you need to draw pair of tangents from the point on the bigger circle. So if I take a point here, that will be P now. If I take a point, that will be P, and here you can observe there is the center of the circles, both the circles. Concentric circles means the circles will have same center. So let us take that point as O here. So from P you need to draw pair of tangents to this circle now, to the smaller circle. So how to draw? How to draw means, see here na, that is very simple. First of all you join O and P. What happens? How to draw? You forget about the outer circle now. You forget about outer circle. If you have an external point and center, how you will be drawing this one? Just you will be taking the perpendicular bisector for what? You will be taking the perpendicular bisector for OP. So how to take the perpendicular bisector? Take more than half radius, draw an arc on the top and on the bottom. With the same radius, take P as center and cut the arcs and draw the perpendicular bisector. Here it will be 90 degrees, and you will be taking this point as M now. You will be taking that point as M. So from point M, take MO as radius now. Take MO as radius and cut the circle here. Cut the smaller circle. We want the tangents for the smaller circle. So take MO radius and M as center. Cut the circle in two parts. Let us take this part as A, this point as B now. Now you join PB and PA. Then there will be the tangents for the smaller circle drawn from a point on the bigger circle. This is also one of the most important questions. First of all you need to draw the rough figure, then you draw the original figure, and you need to write the steps of construction also. Okay, right now, if every time whenever you are watching a video, please do watch it completely. Why? Because there will be definitely one point which is very important for you now. Some students might be knowing one point, some students might be knowing the other point, but if you observe completely, then you can understand the concepts clearly. The next one is, prove that a parallelogram circumscribing a circle is a rhombus. So let us take this one. This is the third problem of exercise 2. This is the third problem of exercise 2 Nana. Right now you can observe a parallelogram circumscribing a circle. The center is O, you can take here, and the parallelogram is A, B, C, D. You should show that the parallelogram circumscribing a circle is a rhombus. So what is the important property of rhombus when you are talking from parallelogram? So rhombus is also a parallelogram, but when the adjacent sides are equal. So in a parallelogram, if adjacent sides are equal, then the parallelogram becomes a rhombus. So already he has given it is a parallelogram. We should prove that adjacent sides are equal here. We should prove that adjacent sides are equal. Okay, for that let us see one thing. Actually you can do this one. If the same problem comes in 2 marks, you can do directly. Why? Because you have a statement which we have discussed in our previous class, that is, when a quadrilateral is circumscribing a circle, there we have one important point. What is the statement is, sum of the opposite sides will be equal now. So if any quadrilateral, not only parallelogram, if any quadrilateral circumscribe a circle, sum of opposite sides will be equal. So what are the opposite sides here? AB and DC. So AB plus CD is equals to, here again this is AD plus BC nana. So see here, sum of these opposite sides and sum of these opposite sides will be equal here. So this is the statement which we have discussed in our previous class itself. So from this statement also you can prove this. That will be very simple. Why? Because see here, this is already in the question itself he has given ABCD is a parallelogram. So you can write here, if ABCD is parallelogram, opposite sides are equal in parallelogram, right? AB will be equals to CD, and also you can write BC will be equals to AD. BC is equals to AD now. BC is equals to AD. Why? Because that is a parallelogram. So try to substitute them here. So here I have CD, I can substitute AB here. So AB plus AB will be equals to, here I have AD plus BC is also equals to AD. BC is also equals to AD. So 2 times of AB will be equals to 2 times of AD here. 2 and 2 gets cancelled. Therefore, AB will be equals to AD. AB will be equals to AD. So here we have proved that adjacent sides are equal. AB and AD are adjacent sides here. If there are two adjacent sides are equal in a parallelogram, then the parallelogram is a rhombus. Hence, you can write here ABCD is a rhombus. Okay, but if the same question is asked in 4 marks, how to write means, see here Nana. So this is a parallelogram circumscribing the circle. So each side is touching the circle at different points here. Take the points. So here I am taking it as E. Here it is touching at F. This is G, and I am taking this point as H. Nana. Clear? So the sides of the parallelogram are touching the circle at 4 different points. What are those? Nana? E, F, G and H. Nana. E, F, G and H. Okay. In the figure, if you observe, AE will be the tangent to the circle and AH also will be the tangent to the same circle. Nana. Both are tangents from an external point. You know one statement. What is that statement? The length of the tangents drawn to a circle from an external point are equal. Right, Nana? So from this statement, what you can write here? So AE is equals to AH. That is the first condition you can write. AE is equals to AH. And also, B is also an external point. BE is a tangent. BF is also a tangent. So again, what you can write here? BE is equals to BF. Nana. BE is equals to BF. In the same way, D is the external point. DG is the tangent and DH is also the tangent. DG and DH must be equal there. So you can write here DG is equals to DH. DG is equals to DH. And the other case, C is the external point, CF is the tangent and CG is also tangent from the same point. So there also the lengths will be equal. Nana. So right here CG is equals to CF. CG is equals to CF. So only one precaution what you need to take here is observe the sides what I have taken first. Nana. AE, BE. See here, first I have taken this one, then I have taken this one, BE. Then DG and CG. DG, 3 and 4. So whatever the sides you are taking, whatever the length of the tangents you are taking on the LHS must be corresponding to the same side. Nana. From the same side you take on one side, then your problem will be simple. So after this, take these statements as equation 1, 2, 3, 4. Okay, so these are the 4 equations. Nothing to do, just simply add them. If you add them, what happens on the LHS? That will be AE plus BE plus DG plus CG. None. Right? Which is equals to, right, what are the sides on the RHS now? AH plus BF plus DH plus CF. Clear? After writing this one, from the figure you can observe what is AE plus BE. AE plus BE is equals to, so this will be completely equals to AB plus DG plus CG. Nana. See here, this is DG and this is CG. If you add both, you will get the side as CD. So you take the brackets like this. So this will be AB plus CD. And even in the RHS, take alternate tangents. AH plus DH, you see here. AH plus DH. If you add these two, first and third one, then you will get AD plus, if you add BF and CF, BF plus CF, which is equals to how much? That will be BC. Nana. Okay, here you should add like this. If you add them like this, then you will get the solution. So see here, AB plus CD is equals to AD plus BC. From this only you got the statement, this one. Okay, so this is the proof for the statement for the if the quadrilateral is circumscribing a circle. If quadrilateral is circumscribing a circle, then sum of two opposite sides will be equals to sum of two other opposite sides. Now, so this is the statement you got, and from there the problem is same here. Okay, this is the statement first. This is the proof of a statement. After writing the proof, then you need to continue if the question is asked for 4 marks, or else directly use the statement, this one, write the statement clearly and then you solve like this. Okay, if adjacent sides in a parallelogram are equal, then the parallelogram is a rhombus. Simple now. But how I am taking the lengths of the tangents on the one side? So see that one. If you have taken BF is equals to BE, then you will not get correct answer, and again you should think very much. So while taking the sides only, be cautious, then your problem will be very simple. I hope you are understanding this class. If you have any doubts, please do comment in the comment section. If you are new to my channel, please do subscribe, and if you like the class, please do like and share with your friends. and whenever you are watching the video, please do watch it till the end. Okay, the next one. So this is the fourth question in your exercise 2. So keep your textbook in front of you and read the problem clearly, then you will understand it. So see here, first of all, there is a circle and a triangle is circumscribing it. Now a triangle is circumscribing it, so that is in some way. So see here, this is one side, so this is the other side. Right now, so this is the triangle circumscribing a circle. Okay, that is a triangle circumscribing a circle here. So what are the things he has given? Means this is A, B and C, Nana, and the point of contact of the circle with BC is nothing but D. That is nothing but D, and he has given some dimensions, measurements here, such that BD is equals to 9 centimeters. The length of BD is 9 centimeters and length of DC is 3 centimeters. It seems done. Okay, and what we need to find here means you need to find the sides AB and AC. AB and AC is equals to how much? That is our question here. So if you observe this thing, for example, let us take O is the center of the circle. Now O is the center of the circle. You know that if a radius is drawn here, it will be 90 degrees to the perpendicular to the tangent. That means here you can observe it is 90 degrees. And also if you take the perpendicular to this side, now if you take the perpendicular again, here it will be 90 degrees. Okay, so but just by looking you can say that it is like a right angled triangle, right? Now why? Because sum of other two sides must be equal here, obviously. So this will be 90 degrees and this also will be 90 degrees. Therefore triangle ABC will be a right angled triangle. In a right angled triangle, you know that hypotenuse square will be equal to sum of squares of other two sides. Okay, hypotenuse square will be equals to sum of squares of other two sides. What is the hypotenuse here? AB is the hypotenuse. AB is the hypotenuse. Clear? So see here how to find means you can take some other points of contact also. I am taking a point of contact E here and a point of contact F here now. Clear? From the figure what you can say, BD will be equals to BF. BD is equals to BF, which is equals to 9 centimeters. Why it will be 9 centimeters and why both will be equal? Both are the tangents to the same circle from an external point B here. In the same way, DC will be equals to CE. Right now, DC is equals to CE, which is equals to how much? 3 centimeters, which is equals to 3 centimeters. Why? Because CD and CE are again tangents to the same circle from the external point C. Here also the length of the tangents will be equal. Length of the tangents will be equal. So CE will be 3 centimeters and also you can see that BF is equals to 9 centimeters. BF is equals to 9 centimeters. Clear? Right. So you should write the reason here. Why? Because lengths of tangents from an external point are equal. So write the reason there. Okay. From the figure, now you should apply the Pythagoras theorem. Let us take AF. Let AF is equals to AE is equals to X. AF is equals to AE is equals to X. Let us take this as X. These both also will be equal. Why? Because those are also lengths of the tangents from the external point A. Okay. So now apply Pythagoras theorem here. That is hypotenuse square, that is AB square, will be equals to sum of squares of other two sides. What are the other two sides here? BC and AC. BC and AC. So from the figure what you can observe there, AB is equals to, AB is nothing but AF plus FB. AF plus FB. So I am taking directly X plus 9 whole square. X plus 9 whole square. And here you have BC. BC is equals to how much? 9 plus 3. 9 plus 3. Right last is, that is 9 plus 3 whole square. Plus AC. AC is nothing but X plus 3. X plus 3 whole square. Clear? Then the problem will be, expand this in the form of A plus B whole square. Don't write X square plus 9 square simply. Okay, this is A square plus 2AB plus B square, which is equals to 9 plus 3 is 12 square, that is 144. 12 square is 144 plus again A plus B whole square formula, A square plus 2AB plus B square. Clear? So here you can cancel x square and x square. If you cancel x square here, the problem will be somewhat simple. So this is 9 2s are 18x plus 81 is equals to 144 plus 2 3s are 6x plus 9. 6x plus 9. So what you will be doing in the next step? So you need to take x on one side and all the constant to other side. So 18x and 6x I have here. So I will be writing 18x minus 6x, which is equals to, I am taking 81 to other side. Meanwhile, this will be 144 plus 9. 144 plus 9 is how much, Nana? 153. So this will be 153 plus 81. Nana. So not plus 81. Plus 81 when it comes here, it will be minus 81. So 18x minus 6x. 18x minus 6x is how much? That is 12x, which is equals to 153 minus 1. 3 minus 1 is 2. 15 minus 8 is 7. So x will be equals to 72 by 12, which is equals to how much? 6. X is equals to 6 now. Is the problem completed after by taking the value x is equals to 6? No. Actually, what we need to find here? We need to find the values of AB and AC. What is AB here? AB is equals to 9 plus x. This will become 9 plus 6, which is equals to how much, Nana? 15. So AB is equals to how much? 15 centimeters. In the same way, AC is equals to x plus 3, that is equals to 6 plus 3, which is equals to 9 centimeters. Okay, therefore AB is equals to 15 centimeters, comma AC is equals to 9 centimeters. That is our answer. Clear now? So in this way you need to solve the problem. I hope the problem is very clear for you. But wherever the reasons are required, please do write them. This is one of the most important problems only. Okay, Nana, let us go to the next problem, that is 8th problem. All the remaining problems we have discussed in yesterday itself, but there are some dimensions. If you follow the dimensions, then it will be okay. The next problem is in triangle ABC, a circle with the side AB as diameter is drawn to intersect the hypotenuse AC in P. Prove that the tangent to the circle at P bisects the side BC. So see here. So see here, Nana. So it is the diameter. AB is the diameter of a circle. Actually, and AB is one of the sides. AB is one of the sides of the triangle ABC, Nana. ABC. Right, clear. So this is the triangle ABC. So what is the question? Once again you listen here. In a right triangle ABC, that means you know that here the angle is 90 degrees. A circle with a side AB as diameter to the a circle with the diameter AB is drawn to intersect the hypotenuse AC at P. To intersect hypotenuse AC at P. So the point of intersection is P here. Prove that the tangent to the circle at P. So if you draw a tangent to the circle at P, if you draw a tangent like this at P, then you should show that this tangent bisects BC. So if I take a point here as Q, he has also mentioned it is Q, it is by, okay. So we should prove that it bisects BC. That means what we need to prove here? We need to prove that BQ is equals to QC. You need to prove that BQ is equals to QC. Then your answer will be completed. And in the figure, he has given one hint for us, Nana. That is, he has shown here these two angles are equal. In the figure itself, in the textbook, he has shown that those two angles are equal. So that is a very simple problem here now. So see here, in triangle PQC, in triangle PQC, what are the angles equal here? Angle P is equals to angle C, Nana. Angle P is equals to angle C. That means the triangle is isosceles triangle, right? The triangle becomes isosceles. If it is isosceles, what happens? The sides opposite to the angles must be equal. So see here, Nana. The side opposite to angle P is QC is equals to QP, right, Nana? The side opposite to angle C is nothing but QP. Clear? These two sides are equal now. So these two sides are equal. Clear? Let us take this as equation 1. And you know that from Q, if you see Q as an external point, QB is a tangent and QP is also a tangent. And these two lengths will be equal. Why? Because the length of the tangents drawn from an external point are equal. So take that one now. So QP QB will be equals to QP. This is equation 2. Why? Because lengths are equal. Lengths are equal. So you write here clearly, lengths of the tangents drawn from an external point Q are equal. So from 1 and 2, what we can say? From 1 and 2, we can say that QP and QP are equal, RHS are equal, therefore LHS must be equal. So QB is equals to QC. QB is equals to QC. QB means this one, QC is that one, both are equal. Therefore, what we can say here? Q is midpoint. Q is midpoint. Therefore, that if this is the midpoint, so tangent drawn at P. Therefore, the tangent drawn at P bisects BC. Hence, proved. That's all. If Q is the midpoint, Nana, then you can say that the tangent drawn at P is bisecting BC. That's all what he has asked us. So that is very, very simple. The hint is here now. In the question you have the hint. If you don't observe that one, again this will be a big problem for you. So see the hint in the question, in the figure. You should also observe the figure carefully in order to solve the problem easily. I hope you have understood this class very well. If you are new to my channel, please do subscribe, and if you don't subscribe till now also, please do subscribe. And wherever the links are required, I am giving the links in the description. Please do watch them whenever it is required. Please, whenever you are watching a video, if I say something, once you check the description, there you may find the links there. Okay, links for the previous videos or whatever the things which are required. I told you to see the past videos, so those links will be in the description. In that way you see here. That's why. Okay, and if you are new to my channel, I told you to subscribe, and even if you are watching my videos and you didn't subscribe, please do subscribe and hit bell icon. If you hit the bell icon, then you'll get the notification. If you like my class, please do like and share with your friends. It helps the channel a lot. Thank you for now. Let us meet in our next class with some other problems related to segments which are very, very important for your examination. Thank you for now. Bye.